Hi dear students, welcome to my channel. This is continuation of fundamentals of physics. Today's topic is Doppler effect. Before that, all my dear viewers, happy Vinayaka Chauthi. Doppler effect in any wave, sound waves we'll discuss now. Doppler effect means when source and observers, they are in relative motion, there will be apparent change in the frequency. This is called Doppler effect. What is meant by relative motion? Relative motion means, suppose I am sitting with my friend in the bus. Bus is moving with respect to the ground, but my friend is not moving with respect to me. So with respect to me, that person is at rest. But actually both are moving with respect to the ground. So in this case, if I am source, if he is observer, there will not be change in the frequency of the sound. Okay? Suppose I am running towards my friend is standing there. I am speaking and running towards him. I am the source. I am speaking means I am producing sound, means I am source. Observer is listening, so he is observer. I am going towards him means source is moving towards the observer. Or I am standing here, I am talking something. He is listening and coming towards me. So observer is coming towards the source. So this is called relative motion. When observer and source are in relative motion, there will be a change in the frequency of the sound. This is a Doppler effect. Now we will derive different conditions. When source is rest, observer is moving towards the source. One case. Suppose observer is moving away from the source. Another case. In these two cases, the frequency will be different. How it will change, we will derive in this video. Suppose this fellow is observer and this fellow is source. S, observer is O. Velocity of the source I am calling Vs. It is rest, so equal to 0. Velocity of the observer Vo. The first case, case 1, observer is moving towards the source. That is the case. Now you see, first case you assume both are at rest. Suppose both are at rest. This fellow is speaking something, he is listening. Now sound is traveling from the source to the observer and he is listening. And time taken by the sound wave, velocity of the sound wave I am calling V, velocity of the sound wave. So time taken to travel from source to the observer I am calling time t. Time t. The distance between observer and source will be V into t. This is a case when both are at rest. But the condition is observer is moving towards the source. Means the sound when it traveled from here to here, in the time the observer moved from here to here. Suppose observer moved here in the time, another time. Now time changes. Both are at rest. The time was t. Now the observer is moving, time will be less because he is moving towards the source. Time will be less. I will take different time, that is t prime I will take. So time taken from here to here, the sound traveled. Sound is traveling from here to here in time t prime. In the same time t prime, observer moved from here to here. So what I can write here, from here to here, observer is moving with velocity v0 in the same time t prime. So into t prime. So this total distance, that is initial distance between observer and source, that is Vt, equal to V naught t prime plus Vt prime. So Vt I will write like this, Vt is equal to V naught t prime plus Vt prime. V is the velocity of sound, already told. You take t prime common. This is, I will write V plus V naught. This is V into t. I will take t prime this side. 1 by t prime is equal to, I will take t this side. So a V plus V naught. V plus V naught divided by V into 1 by t. This 1 by t is the actual frequency of the sound when both are at rest. 1 by t is the frequency. T is a time period, let it be. So 1 by t prime is a apparent frequency what you had. That is not actual frequency. I am calling 1 by t prime as nu prime is equal to V plus V naught divided by V into nu 0. Nu 0 means original frequency. This is called the apparent frequency. There is a change in frequency that you can calculate nu prime minus nu 0. That is a different thing. But the frequency held by the observer when source and observers and relative motion is V plus V naught by V into nu 0. V is velocity of sound, V naught is velocity of the observer. So there will be a change. Means what happens? Numerator is more than denominator. The frequency will be increased. When observer is going towards the source, frequency increases. If observer is going away from the source, in the next class we will discuss. Okay? Now what happened? Observer is moving towards the source, the frequency increased. Next case is observer is moving away from the source. That we'll discuss. Now observer is moving away from the source. Source is here at rest. Observer is moving like this. He is talked something and sound is traveling. And it should reach the observer. It should reach here observer is there, no? Here up to here. So the time taken will be t prime. Original is same. Original is, this is V into t. That I should not change. Original is when both are at rest, the distance between them is V into t. Now what happened? The observer is moving away from the source and sound has to travel further more distance. Certainly this t prime is more than t here. So in this case what happened? The observer reached here. The moment when sound traveled from here and then moved up to here, he is not there. Now he has traveled here. The sound has to reach this position to listen what he talked. So now you see, this distance is what? Traveled by the observer, V0. In what time? In time t prime. T prime. Because sound has to travel from here to here, the time t prime, the moment when he spoke something, when he talked something, that time he started moving along this direction. So time is, the sound is traveling and this observer is traveling. Both met here. So in time t prime, he traveled a distance V naught into t prime. And sound traveled a distance V into t prime. Now what you can write? This distance is Vt prime. Vt prime is distance traveled by the sound. Vt prime is equal to, this distance is V naught into t prime. V naught into t prime. This is the actual, means original, when both are at rest. That is V into t. Why I am taking t? Because t is the actual when both are at rest. The actual distance between them. That's why t. I should not change this. Now you take t prime one side, what you will get? V minus, I will take as Vt one side, you take. Vt is equal to Vt prime minus V naught t prime. You take t prime common, take this side. So 1 by t prime is equal to V minus V naught divided by V into 1 by t. 1 by t prime is the frequency is equal to v minus v naught divided by v into nu 0. Here numerator is less than denominator. The frequency reduces. When observer is moving away from the source, the frequency of the sound heard by the observer is less than actual. In the previous case, observer is moving towards the source, the frequency heard by the observer is more than actual frequency. This change in frequency due to the relative motion between observer and source, that nature, that phenomenon is called Doppler effect. You understood, no? In this video, we discussed source is rest. In the next video, we will discuss observer is rest, source is moving. That cases we will discuss in the next class. Till next class, bye bye, tata.